All right, folks, the next topic is, well, actually, I hit a couple topics, but let's go ahead and address bars and in terms of steel. So, for example, you can actually order just nice, solid, square, or even rectangular steel bars. And you can also order them in round too, and they're more called shafts though in that particular case. But you can order these. Now these don't get typically this big. You know, your common size you're going to see is like 1/2 inch, 3/4 square, that sort of thing. They're used oftentimes in railing, like in handrails. If you're looking off a balcony and you got your top rail, you're going to see these little vertical lines a lot of times. And a lot of times if they're steel, they're going to be steel bars that they just weld to the top and bottom rails. This actually keeps a small toddler from being able to stick their head through. There's actually a code on how much space can be between the two. But this is a bar stock. It's solid, and it can be ordered in square sizes. So someone's going to order a bar. They're going to basically establish the width and the overall thickness, because there is no interior thickness. There's no wall because it's solid. So that's how they order bar stock. Again, your overall dimensions being set up that way. They may use a symbol, or they may just use the term bar in practical set of plans. So not a big deal. That's pretty easy to understand. You do see this symbol though on drawings, and that's a PL, where the P is overlapping the L, sometimes like this or sometimes like this. Kind of depends on how the software is set up and how the designer is doing it, but that stands for plate. So essentially in steel fabrication we use plates for a lot of things, like connections and that kind of thing. Now we use them for like making tanks and stuff of that nature too. We don't use them for flooring, so don't be confused, if we confused metal decking with steel plate. For metal decking has this typical shape to it that is welded down, and concrete's usually poured over it, or some kind of rubber roof or that kind of thing. Steel plate is in itself just a big plate. It might be cut into small pieces. It's going to typically be bought in big O sheets. They can be bought in multiple sizes, 4x8 sheets, depends on what the company has to cut with. And the most key thing about them is how thick they are, because that's going to establish a lot of weight. Now the type of surface, you can have your diamond plate plates, you can have your standard plates, all kinds of things, and they will also have a grade of steel or KSI value associated with them. Just depends on what ASTM standard the manufacturing company may have made. But anyway, we use plates in construction a lot. For example, and I mentioned previously, when we tie beams and columns together. For example, if we have a column here and we have a beam here, and this is just called a W-beam, we're seeing it from the side, and I want to connect this W-beam to this column. Well, you could try to hold it there in place and weld it, which doesn't work out too well. Or you could drill a couple holes in it right about here. You could go get a steel plate of a certain size, drill a couple holes in it. You could weld said plate to column in the shop. And when you get out to the field, you can turn around and bolt this steel beam to that steel plate. And then if you want to, you could add more welding if you needed to. Typically, this is what we refer to as a shear clip connection, or shear, just a shear connection, where there's no actual bending force transmitted from the beam to the column. It's just what we call a pin joint. Another example is what they'll do is they'll actually take plate, see if I can delete this off and leave the other piece, take plate, and we'll do a gusset plate, where we'll take a piece of plate, weld it to the side, and maybe add a triangular piece of plate down below. Looks kind of like this. Here's the top plate, and there's the triangular plate down below. We'll weld it to it again in the shop, and then we got to do field install. We're going to set it right here. I shouldn't have holes on this now because we're not using holes this time. I'll get out to the field, and then I'm going to place it on top of the actual plate, let it sit there, and then I can apply more welds as needed. So plates are used for a variety of connections. I also showed you where you can add a welded plate to it, add a welded plate here, and then use an piece of angle to be a kicker to support that, make the connection stronger. Now, as far as plate size, a lot of times these things will be anywhere between 3/8 plate, 5/16 plate. You can get all the way up to 3/4 inch plate, used for a variety of things. One in particular is the base plate, which is a plate that is actually welded to the bottom of a column, where bolts are put in so that it can be anchored down to the concrete down below. This oftentimes, according to a variety of standards, will be 3/4 inches, depending on how large these columns are and how much stress is going to be put on it. So they'll actually just take 3/4 inch plate, cut it out to a certain size, drill some holes in it, or plasma cut it if they can, weld the column to it, and take it to the field for install. So plates are used for a variety of things. Shop drawings are typically full of plates of different sizes and shapes. And there's a lot of standards in terms of what size these type plates need to be in terms of thickness, width, and height, how much spacing is between the circle or the holes to each other and to the edges. All that kind of stuff is standardized. So looking at shop drawings, you're going to be seeing lots of plate. And that's just one example you might run into. There's lots of different ways they can be used. A lot of times steel plates are used in staircase design, exterior stairs. Diamond plate is used a lot of times for treads on your staircases. Fire this thing back up. If I'm going to actually make a steel staircase, I might do something like this, where I take steel plate and bend it to make this shape. Actually, we'll add a little toe catch there too sometimes. And we'll create a set of stairs this way. We will weld these to a C-channel, running that way. Maybe use a C-channel right here, throw on some vertical rails, and we've got ourselves a steel staircase. So this would be plate. This would be some kind of plate size. The rest of it would be C-channel, and then some steel pipe, which we'll talk about in a second. As far as plate gets called off, a lot of times on a set of plans they may say like a 6 by 3 by let's say 3/8 plate PL. It can come before or it can come after on a set of drawings. You will probably see both. If they get lucky and it's square, then they'll just actually put an SQ or something. Typically, most of the time, plates do show the full dimensions of the plate on a set of plans. Now, I've seen folks kind of lay them out differently. You'll see some that will actually start off with the dimension of the thickness. So they'll say 3/8 plate, 4 by 3, 4 by 5, whatever the case may be. So they may swap out the location of the thickness. Technically, this format is a little bit more standard, more approved, but the designers, they're just trying to communicate their ideas, so they don't sometimes stay to the standard that well. So just be aware that the dimensions could be before or after the rest of the size dimensions or the actual size of the plate. Thickness is a priority, and the PL can be located in 2 different locations. Not necessarily saying it's correct, I'm just saying that's how a lot of people will do it. All right. I want to finish up with another common piece of steel fabrication part, and that would be the good old-fashioned pipe. Now, pipes are used in a lot of variety of construction projects. First of all, obviously you can use them as pipe for running fluid back and forth. Steel pipe used for piping applications nowadays would be like high pressure pipe and that sort of thing. We don't typically use steel pipe for any kind of things other than high pressure or high resistance. So that's one clear example, but another common example is using them for columns. So steel pipe can be welded to a base plate, which can be anchored to the concrete and used for a lot of decoration. People like to use big round steel pipe for columns because they're massive and they can tie the beams to them and they just look cool. And as a result, you can end up welding a lot of shear clips or clip plate to a lot of pipe and creating into beams. So pipes come in a variety of sizes. One of the key things to understand about pipe though is whether you're dealing with ID or OD. And the ID stands for interior diameter. OD of course stands for exterior diameter, which means that depending on the wall thickness of a pipe, there's a diameter value here, which is the ID, and there's a diameter value here, which is the OD. And just so you know, if I can write this correctly here, just so you know, the standards, or it's different in terms of, like say you go order a 6-inch pipe. Well, when you go order a 6-inch pipe, you might get, if you're dealing with one type of application, you might be dealing with interior diameter, where the interior is the crucial. Or you might be dealing with the outside diameter, which the outside diameter might be crucial for a different application. The key thing I'm trying to drive home here is you want to watch out for it. Also, there's about 3 different grades of pipe in terms of like standard, which what we refer to as a Schedule 40 pipe. And then we've got larger versions than that, but this is your standard. If you just go in and order a pipe, that's probably what you're going to get. It's your standard wall thickness, and then they increase. So, to explain it better, let's take a look at a chart, which that should be always your go-to move anyway, is checking out charts and graphs, or the internet for stuff. So for standard, here's your typical wall thickness. Then you can get what we refer to as extra strong, or XS, and then you can get double XS, which is double extra strong, which basically means the wall thickness is the changing. So let's take a look down below. Get this thing to slide down for us. Let's say that you go order a pipe there we go. Let's say you go order a 3/4 inch pipe. Alright, so outside diameter is not 3/4. How about that? Alright, inside diameter, you're going to notice, is closer to the 3/4 inch. Look at this though. The actual extra strong is even closer, and the double extra strong is there. So what's actually happening is, in the outside diameter, what you're actually going to get in a 3/4 inch pipe, you're going to be dealing with a pipe that has an outside diameter of 1.05. The inside diameter is 0.824. So what would be the wall thickness between the two? We'll take a second, see if you can calculate that. What's the wall thickness associated with these two values? Well, the answer, of course, is you take 1.050 minus 0.824, but that doesn't give you the straight answer because it's a wall thickness on both sides. So a quick little calculation gives you 0.226, but that is just the value of the 2. You actually have to divide that by 2 to get the actual value of your wall thickness, which, as you find out if you haven't already checked the schedule here or the chart, is that value right there. This is your actual wall thickness on one side. So that distance right there. Now, look what happens when you switch to an extra strong. Schedule 80. Notice that they call it Schedule 40, Schedule 80, and then double extra strong beyond that, and then here's this. So obviously, if you're going to get a pipe, you're going to be dealing with the Schedule 40 standard, and then if you go higher than that, then you've got more wall thickness and a reduced internal diameter. Notice in this case, though, the external diameter does not change between these sizes. It just keeps getting smaller and smaller on the inside. The outside stays the same. Let's take a look at a 3-inch pipe. Actually, let's take a look at a 6-inch pipe. This is one that is commonly used for columns because they're nice and big and bold. So here we have our actual outside diameter, 6.625. The inside diameter is 0.60, and you're going to find this that in certain sizes, they start to switch direction. For example, they try to hold the inside diameter as being the target. So for example, this 3-inch pipe, notice that its inside diameter on standard is 3 inches. 3.5-inch pipe, it's not the outside that's important, it's the inside, which makes sense because pipe's actually used for flow. So it makes it easier on calculations. When they're not used for steel columns, it makes it a lot easier to use to calculate flows when you know the inside values as opposed to the outside. So anyway, the point is you need to check charts and you need to check the internet when you're actually dealing with certain sizes, especially if you're going to be cutting out parts to work with the inside of a pipe, or even parts to cut out to work with it. For example, let's say that we were going to use a steel column that was a pipe, and we wanted to make a gusset plate that hangs out over the pipe to set a beam on. So we're going to do a gusset down below, triangular plate down below. But as you see, what I have to do is I have to cut out my plate to match the curvature of the radius of the pipe. If I just tried to cut it square, what's going to happen? Well, I'm going to have hardly any ability at all to weld this thing to because I have all these gaps. So we would fire up our plasma cutter, and we would cut it out this way. But how am I going to know what this value is if I don't go to the chart and let's just say that we're using a 6-inch pipe? And we actually did this on a project not too long ago. We used 6-inch pipes to make some really nice columns, but we needed some resting points for some cross beams, so we had to cut the plates out with the included radius. So we would go to a chart, look up the 6-inch pipe, and let's just say we're buying a standard pipe. So we're going to be dealing with, switch over to my pencil here, 6-inch pipe has an outside diameter, and that's why we're concerned. We're not too concerned about the inside in this case because we're not welding anything on the inside, we're welding the outside. So it turns out that this thing has a 6.625. If I were going to calculate the radius of that, all I got to do is divide this number by half, and we would get a 3.3125 radius value for us to design our plates with that would work out. And then, like I said, we did it, worked out pretty good. Now, granted, this stuff that you're seeing here, these charts, are not necessarily industry standards. They're going to be close, but not necessarily exact. So some manufacturers actually provide this kind of thing, but there is some standardization. And honestly, in most cases, big steel fabrication, you know, you can use some non-standard stuff, or you can use like these basic charts like this and probably get what you're dealing with. The variations that you're going to see are going to be very small and probably won't matter in your cuts and those kind of things. Now you may see the term MPS, and if you do see that term, that just means nominal pipe. Nominal pipe size, sorry, left off the S there. Nominal pipe size. You don't see MPS that much on set of plans though, but you may see it thrown around the manufacturing data. Alright, so that brings us to kind of a closing up, and learned a lot of stuff here. So we've got pipes, we've got plates and everything. By the way, there is one other term associated with some of this stuff. So if I can get this thing, well, there's always, we talked about plate, but there's also sheets. So sheet steel or sheet, if you're dealing with that terminology, that essentially means you're dealing with a plate, but it's a very thin plate. So like I think the cutoff is about an 1/8 inch or less. So if it's bigger than an 1/8 inch, it's probably considered a plate. If it's less than an 1/8 inch or less or something, you're probably dealing with a sheet. So for example, metal decking would be considered sheet steel versus like, plate steel. All right? But that's something you can probably easily figure out. As far as how they would be shown on a set of plans, probably going to be about the same there, but your thickness is the difference. All right? We don't really use sheet metal for any type of structural work. We use it for roofing and surface coverings and those kind of things. So you're not going to be doing a whole lot of heavy fabrication with sheet materials other than just kind of like finishes and such. All right, so that wraps us up. Hope you've learned a lot with a lot of these steel structurals and shapes. I do enjoy putting a lot of this stuff together and building things with it. So don't forget, you can always internet search and find pictures to guide you through if you don't necessarily understand what you're thinking about when you look at a set of plans, or what you're seeing when you look at a set of plans and it has these callouts. Make sure you take a few notes on those callouts, because that's the kind of thing that you'll definitely be tested on and we'll see in the field. And of course, by callouts, I'm talking about when stuff's just listed. For example, this column might be listed as a pipe, but they're going to basically show you the diameter of 6 inches, and if they don't add XS or XXS, that means that it's just standard pipe. They typically don't get into a whole lot of extra deviation with this. Now, of course, we would look at the chart and find out that the 6 is not truly the outside diameter 6, so we'd have to watch for that. All right, but call outs and be able to identify what a sheet is and what a plate is on a set of plans, or what an angle is, that's the kind of thing that you want to be able to do with this information. All right, we'll see you.